All right, let's get to the part everyone loves the most. Let's crunch some numbers. Let's actually put our hypothesis to the test. So you might remember our example that we've been carrying through this. We had 30% of adults sleepwalking. We had our claim, and then we made hypotheses based on that claim. Our focal point is 30% proportion. So our alternate hypothesis, the one we're going to use to test against our null, is not equal to 30%. We picked the significance level because we didn't have a reason to pick anything else. We chose 5%, 0.05. And we'll see how that comes back to bite us or not when we get towards the end of this. But before we do that, we have to test our hypothesis. And so there's a couple ways to do that. One involves technology, and one involves good old-fashioned number crunching. And I'll explain both to you here in the next couple of videos. If you're doing it by hand, what you'll do, and I know this is a lot of information, but a lot of it you already know, is you will make a test statistic. The statistic you make depends on the parameter you're trying to test, right? If you're trying to test proportions, you might remember when we talked about estimating population proportions, we had some requirements. It formed a normal distribution for the sample, and we used for our critical value a z-value, a z-score. And this is now going to be how you calculate your test statistic, your z-test value, basically. Similarly, if you don't know the standard deviation of a population, you can estimate the mean using a t-distribution. If you do know the standard deviation, you can use a normal distribution, which is nice because that's again a z-test. It's again a z-value. Or you can still use the t-table, so you get a t-test going on there. And then finally, the sad one. If you want to talk about variance or by extension, right, standard deviation, just by square root and all that good stuff, you can do that. But again, you'll have to use the chi-squared statistic there. That's the sad one. But anyway, in all of these events, what you'll do is you will find what is ultimately going to be called for us a p-value. You're going to take your test statistic, whichever one it is you're trying to test, and you will use that to create a p-value, which is, in so many words, the probability that the sample you got, that the test statistic you found from your sample was produced by random chance given the null hypothesis was true. That's a lot to take in. But again, assuming the null hypothesis is true, whatever your null hypothesis was, whatever your focal value was, given that that was true, what's the probability that your sample that you measured came about the way it did? So I'll skip ahead to, I'll skip around here in a second. But so again, for the sleepwalking example, we again had the claim of 0.3 as our proportion. We had our null hypothesis and our alternate hypothesis. We picked alpha, and now we got data. We tested 27 adults randomly, and we found 5 people who sleepwalked. Don't ask me how we got that. I don't know. But that's our data. So the p-value that we're going to shoot for here is what is the probability given that 30% of all adults sleepwalk in their lifetime, given this being true, what's the probability that we get 5 out of 27 in our sample? That is what the p-value is. And there's several ways of finding it. We can use the test statistics. We can run simulations. We can run a lot of simulations using online calculators or Excel or R or any of the proprietary softwares. And we'll look at all these examples in the next video, maybe too. But for now, I want you to understand p-values are critical. And that pun is, I'm sorry,